Friedel-Crafts reaction, specifically Friedel-Crafts alkylation. This is today's lesson. In this lesson, we are going to learn alkyl and acyl groups, Friedel-Crafts reaction and definition of Friedel-Crafts reaction, mechanism of Friedel-Crafts alkylation, and finally importance of anhydrous aluminum chloride. So let's begin. The very first point is alkyl and acyl groups. Let's see. When from alkane one hydrogen atom is removed, then alkyl groups are obtained. For example, from methane, if one hydrogen atom is removed, then methyl group is obtained. From ethane, one hydrogen atom is removed, then ethyl group is obtained. From propane, one hydrogen atom is removed, then we get propyl. So methyl, ethyl, propyl, these are alkyl groups. Alkyl groups are denoted by R. This is capital R, indicates alkyl groups. Now let's see acyl groups. General formula of carboxylic acids is RCOOH. This is alkyl. When from carboxyl group this hydroxyl group is removed, then a group is obtained which is known as acyl group. For example, CH3CO, this is acetyl group or ethanoyl group. C2H5CO, this is propanoyl group. This is benzoyl group. So these groups are acyl groups. Ethanoyl group or acetyl group, propanoyl group, and this one is benzoyl group. These groups are acyl groups. Let's move on to the next point. Now the point is Friedel-Crafts reaction and definition of Friedel-Crafts reaction. Friedel-Crafts reaction. In the year 1877, scientist, French organic chemist Charles Friedel and American chemist James Mason Crafts discovered a chemical process which is known as Friedel-Crafts reaction. Let's write the reaction first. This is benzene. Each carbon atom carries one hydrogen atom. When this benzene is treated with alkyl halide like methyl chloride in presence of anhydrous aluminum chloride, then this hydrogen is replaced by methyl group. Methyl group here bonds to this carbon as electrophile, and this hydrogen breaks away as electrophile. So this reaction is a kind of electrophilic substitution reaction, and the product is methyl benzene or toluene, and ACl is produced as byproduct. So this is the reaction in which inclusion of alkyl happens. So this is a kind of alkylation which is known as Friedel-Crafts alkylation. Another part is when this benzene is treated with acyl halide like ethanoyl chloride in presence of anhydrous aluminum chloride, then this hydrogen is replaced by acyl group which bonds to this carbon as electrophile, and this hydrogen moves away as electrophile. So this is a kind of electrophilic substitution reaction as well, and we get here this compound methyl phenyl ketone which is known as acetophenone, and ACl is formed as byproduct. This is aromatic hydrocarbon, this is aromatic ketone, this is toluene, and this is acetophenone. These two reactions together, Friedel-Crafts reaction. Let's define Friedel-Crafts reaction. In presence of anhydrous aluminum chloride, benzene reacts with alkyl halide to form aromatic hydrocarbon through alkylation, and when benzene is treated with acyl halide like ethanoyl chloride in presence of anhydrous aluminum chloride, then acylation occurs, and as a result aromatic ketone is produced. This type of reaction is known as Friedel-Crafts reaction. In the year 1877, French organic chemist Charles Friedel and American chemist James Mason Crafts discovered this reaction. Now this reaction is known as Friedel-Crafts reaction. In this lesson we are going to learn mechanism of Friedel-Crafts alkylation. This is Friedel-Crafts alkylation. This one is Friedel-Crafts acylation. In the first process, alkylation occurs, and in the second process, acylation occurs. Now we will see mechanism of Friedel-Crafts alkylation. Now the point is mechanism of Friedel-Crafts alkylation. Let's see mechanism step by step. Step 1. Alkyl halide like methyl chloride interacts with anhydrous aluminum chloride to form methyl radical and tetrachloroaluminate ion. This reaction happens in two steps. Step 1. This methyl chloride undergoes a heterolytic fission in presence of anhydrous aluminum chloride in this way. Methyl cation is formed and chloride ion is formed. Step B. this chloride ion combines with anhydrous aluminum chloride, which is a kind of Louise acid. Aluminum chloride turns into covalent compound, and now around aluminum there are 6 electrons, which is not octet fulfilled. So aluminum needs another 2 electrons. So this chloride ion forms coordinate covalent bond with this aluminum chloride to form tetrachloroaluminate ion. So methyl chloride reacting with aluminum chloride, methyl cation, that is electrophile, and tetrachloroaluminate ion is formed. Now let's see step 2. Step 2 is this methyl cation, which is electrophile, interacts with benzene. Benzene is electronically rich compound, and this is electronically deficient entity. So it combines with benzene with any carbon atom, and as a result this is formed hydrogen, here methyl group. As this is positively charged radical electrophile, so inside benzene ring positivity is created, which is known as sigma complex. In the sigma complex, to diminish this positive charge, covalently bonded electrons of carbon and hydrogen move towards benzene ring to diminish this positive charge, and as a result this hydrogen is freed as electrophile and toluene is formed. The covalently bonded electrons of this carbon-carbon bond do not move here because electronegativity of this hydrogen is 2.1 and carbon is 2.5. That is why covalently bonded electrons of carbon hydrogen bond move towards benzene, not these electrons of carbon carbon bond, because of the electronegativity difference. Now this hydrogen, step 3, that is this proton combines with this ion, tetrachloroaluminate ion, to form aluminum chloride again and HCl. This aluminum chloride here acts as catalyst that remains unchanged after the chemical reaction, and in this reaction toluene is formed and HCl is produced as byproduct, and aluminum chloride remains unchanged after the chemical reaction as it acts as catalyst in the reaction. This is mechanism of Friedel-Crafts alkylation. Let's move on to the next point. Now the point is importance of anhydrous aluminum chloride. Let's see. Anhydrous aluminum chloride reacting with alkyl halide forms alkyl electrophile and tetrachloroaluminate ion is formed. So here anhydrous aluminum chloride forms electrophile, alkyl electrophile, but when it is moist aluminum chloride, that means water is present there, then This aluminum chloride is hydrolyzed in presence of water to form aluminum hydroxide, and hydrochloric acid are formed. So when it is moist aluminum chloride, then this aluminum chloride hydrolyzed in presence of water to form aluminum hydroxide and hydrochloric acid. But to produce electrophile, anhydrous aluminum chloride is required. So this is the importance of anhydrous aluminum chloride that produces electrophile in Friedel-Crafts alkylation. This is all about Friedel-Crafts alkylation. No more today. Thank you very much.